Hey, all right. Good, good afternoon, everyone, and welcome to Deep Tech Showcase's Space Showcase. With me, we have a lot of very interesting people that we're going to introduce shortly. Today's agenda is going to be opening remarks and introduction to the panel, and then we are going to have two sessions. What is Deep Tech Showcase and why do we do what we do? It's a good question. Essentially, what it is that Deep Tech Showcase's goal is that there's a lot of tech out there that is really relevant for a lot of different folks for a lot of a plethora of use cases. But when it comes to getting the tech into the right hands or actually commercializing, we see kind of a drop off. So our goal is to connect startups to tech scouts, whether they be government or investors, or government or corporate to the startups as well as startups to investors, with the goal of getting the tech to the right people in the right places and having it all kind of come together. And so we have two different ways we do this. One is we have showcase events. You're on one. Welcome. Every month we have a different topic, and we'll get into the next month's topic soon. But essentially, we have about somewhere between 8 to 15 companies present their technologies and give us some background, and hopefully we get some good questions and maybe even make an introduction or two. If you see a company today that you like, feel free, don't be shy. I kind of hack everyone in China about getting to send their information in the chat, like Tom recently made fun of me for, which is good, healthy. I like it. That being said, if you want to make a connection, we're happy to try to make that connection if it's relevant, and happy to get bring people together. That's the goal here. And then there are also guided introductions, which are kind of the segue into that. If you don't see companies you like on here, but you're interested in finding companies, we're always happy to help assist. Our goal is obviously to bring more deep tech to market. And so obviously if you want to see, let's say, autonomous companies for space applications that don't present here, we're always happy to see if we can make the connection, or maybe some other folks here may know some people. So it's a good place to network. The upcoming two showcases are the Future of Computing Showcase in November before the Thanksgiving holiday, and the Aerospace and Defense Showcase in January. And with that, I'll give the floor over to Yoav. Yoav is going to tell us a little bit about our sister company, Eagle Point Funding.
So hi everybody. Can everybody see me okay and hear me okay? So I'm always happy to be a part of the showcase as the least interesting person in the room, because nobody here came to hear me or see me. They came to see the awesome companies. What we do at Eagle Point, our job is to help you get multi-million-dollar grants and contracts from the federal space. Now, the question you should be asking, or you're probably asking, is how can you talk about federal grants and budgets when there's a government shutdown? And that is kind of funny, but the question that you should be asking is there going to be a government shutdown in the next year or in the next 90 days? If you think that's going to happen, stock up on like food and water and essentials. But assuming everybody understand that that's not going to happen, and within the next 3 weeks things are going back to business, then there's going to be a fire hose of solicitations of programs or budgets that are going to go into the Department of Defense, into NASA, into National Science Foundation, into the Department of Energy. Our job is to make that pain-free, not as annoying as it sometimes is, and finding either the right contact or the best narrative and how to put the actual proposal that you're writing as about 50% off your plate and into hours, and making it faster and more professional. So we submit 500 to 1,000 of these every single year. We have an amazing success rate. And I'm happy to see some of the people here in the panel that are clients, and some of them are dear friends for a while. And I'll leave it at that. Anybody who wants to speak with us can either scan the QR code or just go to yoav@eaglepointfunding.com. Today I coined the term, we put the fun back in funding. I don't know if that's a title that we should keep in the long term, but long story short, we make grants accessible, understandable, systematic, with very high chances of winning. So if you're here and you're looking to actually put a form with the government, you should speak to me. And I'll leave it at that. I'll let the rest of the awesome companies pitch and present themselves, and wishing us an awesome event. Thanks, everybody.
Oh, hey, thank you, Yoav. Thank you. All right. With that, we'll move on to our agenda. We're gonna start off with Tom. I hope you're ready, Tom. I hope you practice your all of your voice. No, just kidding. And then Sky Mapper, followed by Inosys, and then Hybron. And for the second session is AGC Power, PyLogic, Red Ascension, and GSpace. And now we will introduce the panel. Before I do, I want to make a note because I used to forget to say this before every single showcase, but now I'm getting better. Essentially, if you do want to ask a question as a panelist, you have two options. One is that there's a reaction button on the bar that basically allows you to raise your hand. That is the most orderly way of doing it, and we're happy to have questions. If you cannot find that button, feel free to just pipe in. We'll try to make it work. We'll try to accommodate. That being said, orderly is good, but also piping in is good. We want as much back and forth engagement as possible, very obviously. And with that, I'm going to go around and ask each panelist to introduce themselves and give us a little bit of background or some information that could be relevant to some of the folks presenting, so that they can present as well as they possibly can. With that, we'll get started on that round robin. Robert Yancey, you want to start us off?
Yeah, Bob Yancey. I'm the Director of Business Development for Hexcel Corporation. We're a U.S. headquartered firm, but global operations, and we're one of the largest suppliers of carbon fiber composite materials to the aerospace industry, including space.
That's awesome. Thank you. All right. Next up, we have Katie Person.
Hi, I'm Katie Person. I'm a career military officer in the U.S. Army. I'm an Army acquisitions officer, and I'm presently a battalion commander in the Army Reserve.
Awesome. Thank you for joining us. Next up, we have Andres Blanco.
Hi, everyone. Nice to meet you all. I am an associate at the Lockheed Martin Ventures, the corporate venture capital arm of Lockheed Martin. So yeah, looking forward to listening to that.
It's a pleasure to have you. Mike Telside.
Hey, good morning, good afternoon, everyone. Mike Telside here, Space Force officer stationed in Los Angeles. Right now, I'm currently the deputy branch chief for mission protection for all the space sensing. I'm looking forward to hear the pitch today.
Thank you for joining us. All right, next up, Marissa McGinnis.
Good morning. I'm an investor, and I'm currently looking for some SpaceX stock directly from some of the employees. Thank you.
It's a pleasure to have you. Lee Silvestri, you're up.
Sure, thanks. I am currently with NavalX. I work for the Navy, reporting into Washington, and I run the North Atlantic Tech Hub, which means I sit outside the gates of the Navy, within the community, working with the investment groups, with high tech, mostly blue tech maritime, but I do work across DoD and DIU, as well as with academia, to help advance the technology along a continuum to get it into program of record.
Awesome. It's a pleasure to have you. Next up, we have Paul Garcia. Paul.
Sorry, two microphones. Paul Garcia, we're with the Air Force Office of Energy Assurance, contract support from Booz Allen, and we work on utility-connected energy systems. That's both power and water. Always happy to be here. Thanks.
Absolutely. Pleasure to have you. Next up, we have Craig McClellan.
Hi, everyone. Craig McClellan. I'm with the Canadian government. Work with the defense industry here in Canada and around the world, helping to make connections and, find new technologies and work with folks who are looking to do more business with the Canadian military. Thank you.
Absolutely. It's always a pleasure to have you. Next up, we have Brandon Kortokrax. Sorry if I mispronounced that.
No, that was good. Yeah, Brandon Quartercracks. I'm a principal at E2MC Ventures. We're a space-focused early-stage venture fund based in Arlington, Virginia.
It's a pleasure to have you. With that, we'll get started. Tom, if you want to start sharing your screen, you could go right ahead. Hope I didn't miss anyone. If I did miss anyone who's supposed to be on the panel who I did not get to, feel free to remind me of the Q&A. But Tom, you're free to go. You're free to start.
All right, so let me know if you can see it. I'm just setting up here. I said it good to go.
We can see it.
Okay, excellent. So I'd like to begin by thanking PPF and DPET Showcase for giving me this opportunity. As you all pointed out, this is true. It's been a lot of fun in fundraising for me, especially having worked with Barker and Europe for several years now. So I highly recommend you to work with them if you haven't already. And so with that, hello everyone. My name is Dr. Thomas George. I'm the founder and CEO of SarniaSat Incorporated. SarniaSat is aimed at monetizing global signature-based geospatial analysis through high-performance edge computing of H-cubed Earth observation data on board low Earth orbiting satellites. First off,
Tom, the audio is a little bit garbled if you want to use a different microphone.
Oh, maybe I should get closer. How's that?
Yeah, it's a little bit better, I think.
Okay. Sorry, I'm working off of a laptop remotely, so it's a little tricky.
All good.
All right, then. So I hope it's advanced to the second slide.
Yep.
Okay. So first of all, what do I mean by H-cube? I contend that unless we have high information complexity in Earth observation big data with high spatial resolution, high spectral resolution, and high temporal resolution, we simply cannot have unique signatures of the phenomena that we're trying to observe. And so as a result, the uncertainties are very high in current observation solutions in the form of false positives or misidentified events and false negatives or missed events. In low profit margin businesses such as agriculture, both false positives and false negatives lead to significant cost impacts on the farmer's bottom line. Whereas in defense, this leads to collateral damage, lost lives, equipment, and mission. From a global commercial market perspective, SarniaSat's H-cube solution will not only have an explosive impact on the current global precision agricultural market and the global defense data market, but also on many diverse verticals that depend on timely and actionable Earth observation information. SarniaSat is attempting to solve what we call a DARPA-hard challenge that has not been solved in the 50 years of existence of both government and commercial Earth observing satellites. This DARPA-hard challenge is that signature-based daily early warning and surveillance on a global scale does not currently exist, despite the enormous amounts of satellite Earth observation data that has been acquired thus far. Reinforcing this point with agriculture, I show on the right side that crop-specific signatures are very subtle in space, time, and spectral. In this case, these are spectral fingerprints of various crop types, as well as disease types, etc. And it requires a lot of complexity to distinguish this. And without a robust H-cube signature-based approach, satellite-based Earth observation has not yet been able to make a dent in timely business decision-making in the agricultural sector. Case in point, the stock price of Planet Labs which is currently the market leader in commercial LEO satellite Earth observation, has been tanking since its IPO in 2022, primarily because it just could not commercial sustainable revenue. In the 9 years of our existence, we have steadily worked our way to our ultimate goal of launching and operating our very own HQ satellite constellation. We have gained significant traction through non-dilutive commercial and government contracts from Bayer Crop Science, NASA, and 9 US Defense Department SDIR awards, with a focus on developing high-performance edge computing solutions for processing Earth observation big data on board the satellite. Some additional honors for SaraniaSat include highly competitive selection and admission into several leading commercial and defense accelerators. In July of this year, SaraniaSat demonstrated for the first time on board the International Space Station complex high-performance edge computing to identify a single flying airplane close to Dubai. I have provided the link in the chat of the blog that describes this achievement. This accomplishment is an important foundation stone, if you will, for SaraniaSat's ultimate HQ strategy. The key component of the demonstration was an innovative cloud-native containerized computing approach to distill the HQ signatures into customer-specific insights. By the way, I believe this is the first demonstration of cloud computing in space that I am aware of. Working closely with L3 Aerospace and Intelligence Systems, SaraniaSat has designed an HQ-15 satellite constellation, generating a whopping 155 gigabits per second per satellite. Therefore, combined with our innovative space satellite-specific high-performance edge computing solution, SaraniaSat plans to deliver signature-based actionable information daily at any point on the globe for both our agricultural and defense customers. Finally, SaraniaSat has been very fortunate in assembling a highly capable multi-institutional and multidisciplinary team to address this hard challenge of realizing our proposed high complexity and low latency HQ signature-based information delivery approach at any point on the globe. And with that, I'd like to thank you for your attention, and I'm ready to take any questions.
Sure, absolutely. Yeah. Whoever wants to ask Marissa, go right for it. You're muted, I think. Yep.
Yeah, I am. I like your background. What are H-cube signatures? I could understand maybe 1 in 10 words of your presentation because it's garbled.
Sorry, I'll be closer to the mic again. H-cube means that you look at information on 3 axes: time, space, and spectrum. So I contend that only if I have high resolution in all information axes, you can get a signature. Oh, I'm so sorry. What's going on?
Okay, let me ask simple questions. That could be yes or no. Is this hardware or software?
It's primarily a software solution. Can you hear me?
Is it developed, or are you doing a prototype?
And demonstrated it on board the International Space Station. So that link that I posted in the chat is to a blog that talks about cloud computing of big data on board the International Space Station as a precursor or a foundation for the ultimate satellite station high-performance computing. Oh, sorry.
Still can. Yeah.
Wow.
It's unintelligible. Okay. So you have.
I should. I should.
Is it satellite agnostic?
Oh, okay. So maybe he can't either. I'm
Is
so
it
sorry.
satellite agnostic?
Yes, satellite agnostic. Can you hear me?
All right. And then are you getting revenue for this already, or is it just being tested?
It's being tested.
Okay. Okay, thank you.
Oh, you're welcome. Thank you.
Absolutely. We have time for more questions. I think there might be a few in the chat.
Thank you. Can you hear me? Or no? Hello, Michael? Oh, I'm so sorry. I have no idea why my audio was not working.
Yeah, someone said your mic is too hot. Okay, Lee, do you want to give it a shot?
Yeah, please. Tom, thank you for your presentation. So my question is, given where we're going with AI, and I know I'm jumping a few steps ahead of where you're probably ready to address, but where AI intelligent systems are going, can you speak to this being a critical feed in the ability of AI to do certain calculations, to do certain processing, please?
Absolutely. The information that AI has to deal with is all as the information that is acquired, right? Can you hear me? Okay.
Yeah.
So the point is that unless you have high resolution information in space, time, and spectrum, you have a unique signature that fits that phenomenon. So suppose you're trying to distinguish a ship, an enemy ship, for instance, and identify it. Then you look at signature of time, space, and spectrum.
Okay, thank you. One other follow-up then, if you don't mind. Given the mechanism you're using to do your calculations and to address the technology, is there any transferability to subsurface?
So it's sensor agnostic, and so you can use it for any sensors that use subsurface.
Okay, thank you.
Yeah.
Absolutely. Perfect. Thank you so much for the presentation, Tom. And yeah.
So sorry about the audio. I don't know what happened, but you know.
You're good. It happens. But yeah, all good. But anyone who wants to connect with Tom offline, feel free to. I know he's already ready. He's already ready with his information. Perfect. And so next up, I believe we are.
Thanks very much.
Absolutely. I believe we're gonna have Inosys. And so feel free to start sharing whenever you're ready. Sure. Let's see. I think we're running a little early, everyone. Oh, okay. Well, while we're waiting, I'd like to introduce Carmelia Jones, who's also with us as a panelist. If you want to quickly say hello, feel free.
Carmelia Jones. I'm a Space Force officer doing a congressional fellowship on the Senate side.
Nice. It's a pleasure to have you. And then also Max Jurgen.
Hi, I'm Max Jurgen with Space Leasing International, SLI. We help fund companies in the space ecosystem as well as across the aerospace value chain.
Nice. Pleasure to have you as well. All right. So now I believe Inosys should present. If you guys are ready, feel free to start sharing. Let's see. I think we're running a little early. Larry, if you want to start presenting, you can. Yeah. Larry, can you hear us?
You guys hear me?
Now we can.
Okay, good. Okay, sorry, let me get my slides in a, hope you
Sure.
can see it now. Can you see my slides okay?
Not yet.
Great. So, we're going to talk today about our solid-state vacuum device technology, designed for extreme environments and also for high-frequency applications for space to Earth communications. Okay, hopefully. Sorry, my slides is going a little slow. So the need that we ask are the following. There's increased security and defense applications requiring high performance electronics. They're essential, of course, electronics are essential for exposure to extreme conditions, which are unavoidable sometimes, especially uh, 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 for
Larry, you're cutting out a bit.
power supplies. And
I think we lost him.
sorry about that. I'm in transit, so it's may drop out a little bit. Let me go back to sharing again. I guess I somehow lost it. I apologize for that. Can you hear me okay?
Yeah, we can hear you now.
Okay, good. Maybe want to stop. Okay, so let me get back into the slide mode again. See, so okay, so let me continue onward. Okay, let's see. All right. Can you guys still hear me?
Yep.
Great. Don't know why I guess it's the graphics are taking a little time. The physically insensitive to radiation, temperature, EMP, they operate at high power, high frequency and voltage and temperature. They're basically immune to both radiation and EMP. And they allow, essentially high operating power without the necessity to cool, increasing efficiency while reducing system as power and supply complexity, size, weight, and cost. Basically, we can operate up to about 500 degrees C easily in any ambient, and we can go as high as 650 and above. Our vision is to empower next generation of electronic systems that function reliably in increasingly harsh emission environments, unlock sustained performance in space, hypersonics, and nuclear domains, extend electronic dominance and survivability to human and radio frequency critical role in electronic warfare, communications, networking, surveillance and reconnaissance, remote control, etc. What we try and solve is we bridge the gap between innovation and survivability. Today's advanced electronics can degrade or fail under radiation, temperature, and or EMP. And then, of course, mission success depends on electronics that endure and perform. SSVD-based electronics do not degrade even in harsh to extreme environments. We can continue to develop new circuits for customers' needs, which are not satisfied by competing technologies. And the core technology is basically our platform of SSVD, which we can divide into two product lines. millimeter wave, and terahertz. And also basically harsh environments for lower frequencies and DC electronics. And again, they're suitable for high temperature, EMP shock and vibe, and cumulative TID radiation dose environments. We've also developed a line of high voltage power supplies and integrated power conditioning required to power SSVD-based millimeter wave and terahertz power devices and power sources, as well as other high voltage devices. This is in-house, and we can do these at the subsystem level. We have full turnkey processing at our facility, including SMT, full line of SMT pick and place machines. I'll go through this really quickly. I know we're running out of time. Electron transportation is in a vacuum. We use solid state fabrication and construction, just like microelectronics, just like solid state semiconductor microelectronics. Our devices behave like field effect transistors. We also refer to them as a vacuum transistor. Consists of both active and passive devices, capable of a broad range of circuit functions. Can be built on most dielectric or semiconductor substrates, including silicon carbide, gallium nitride, ceramics like zirconium oxide and aluminum oxide. We can integrate sensing, comms, transmitting, and control in a rad, hard, and sensitive platform, scalable and integration level. We've demonstrated RF and microwave amplifiers, transmitters, op amps, digital logic, various high voltage switches. Again, can be integrated with other technologies such as silicon carbide, applications for satellites, hypersonics, and nuclear systems. Showing the bottom is an example of one of our SSVD small cell integration ICs built on a silicon substrate. In the left middle is an op amp built on alumina oxide. And then there's an IV curve taken before after 500 C testing at NASA. And then there's a high frequency gain of our S-band power amplifiers tested up to 550 C operation environment. And then I won't go spend too much time on the competitive advantages because I know we're running out of time. Most electronics fail below above 500 C. Sorry, did I stop now? Okay, I'll stop now then.
No, you're good. You still have a few minutes.
Okay, good. Thank you, Asher. So most conventional semiconductor electronics fail above 400 C. Gallium nitride, for example, silicon carbide can go higher, but it's limited in frequency response. They degrade or fail beyond 100 megarads of radiation, sometimes even like 300 kilorads. They require shielding and redundancy to mitigate radiation. Semiconductor lattice causes drift and damage over time and also mobility degradation, both due to radiation and due to temperature increases. And of course, threshold shifts and leakage currents take place with increased total ionizing dose radiation. High power draw and loss at temperature extremes for RF applications. Short operational lifespan, 3 to 7 years typical, at high to extreme temperature environments. Ours have already been demonstrated to up to 650 with no cooling for engines, reactors, and other heat sources. We survive much greater than 1 gigarad total dose, truly immune. We don't need any sort of shielding. We've been tested, to pass ICBM missile launch, shock and vibe. We can do it on ceramic substrates, low-cost substrates, using the same type of fabrication tools as used for semiconductors. We can demonstrate greater than 50% RF efficiency across wide temperatures, 20-plus year lifetime, and dual-use readiness. And some of the benefits are high performance, improved SWaP plus C, operates in environments competitors can't reach, enables missions near heat or radiation sources on high temperature terrestrial and planets without extra cooling, can survive nuclear reactor operation, it can survive nuclear, obviously it can't survive the physical, explosion itself, but can survive neutrons, betas, gamma rays, etc. There's no need for further hardening. It can lower total mission costs and risk, and it can be across domain applicable. Our traction so far has been with AFRL, AFMC, the Army, the Air Force, nuclear facilities, NASA, DOE labs, defense contractors.
Perfect.
And I think that's pretty much it.
Awesome.
Asking roadmap. we're looking for, industry adoption for partners, especially larger primes, basically system integrator, defense contractors and things like that. We're engineered for harsh environments, again, including radiation, extreme temperature, and EMP resilience, and we can be more cost effective overall. We recently awarded an AF Works Manufacturing Challenge Direct to Phase 2, SBIR, and we plan to address custom-made components needed as demand arises, build commercial off-the-shelf components. We also are doing high-temperature PCBs, printed circuit boards, and high-temperature passive components go with that. And so basically, we want looking again at equipment houses, integrators in each application area. We like to partner with prime defense contractors for military and civilian transitions and support current known needs while developing new potential military end users. Our ask is Air Force partners for TACFI, STRATFI, and DoD partners for other DoD post-phase 2 programs, for example, MDA SHIELD. And investment money in exchange for royalties, pre-sales, or combined thereof. The team consists of Dr. Jennifer Hu is our co-founder and chairperson and CEO and president. She got her PhD from UCLA and was a professor at the University of Utah for a number of years and has been with the company since inception. I'm also a co-founder and the CTO. I also did my PhD in electrical engineering at UCLA and also was a tenured faculty at the University of Utah before coming to work for co-founding and coming to work for Inosys. I've worked for Unisys, Xerox, and TOW, which then became Northrop Grumman. And our CMO has over 25 years of experience with major companies. And that's basically it. If you have any questions, you can please contact us, or we're happy to answer them right now. Thank you, Asher. Thank you for the time today.
Yeah, absolutely. Yeah, we have some time for questions if anyone wants to jump in. Okay, Lee, go right ahead.
Yeah, so very compelling. To me, it sounds like it's SSVD is like a magic bullet. It's like the holy grail of electronics. Very heavy and intense on the what it does, the impact, the results, how it outperforms. In my world, very light on the how. So I think if a person like me were to help sell this into DoD or applications, some better understanding, it could have been just the communication at the upfront part of this. Need to know a little bit more about the how.
Yeah, thank you. I think it's a very good question. We're happy to have a separate meeting with you if you'd like to. This was put together by our CMO, and so it's more of a, I guess, a presentation, not so much technical in details, but certainly we'd be happy to go through it all with you. We have other slide decks. Yeah, so we combine basically the advantages of, to make it kind of simple, vacuum devices, in the olden days were glass tubes and things like that. We combine the advantages of vacuum electronics, where the media of transport is vacuum, with the manufacturing techniques that have been developed over the last 30, 40 years to the present for both microelectronics and MEMS and micro engineering, basically nano engineering type of thing. So we use modern technology to build these devices in a reproducible, essentially touch-free, hands-free environment using sputtering and electron beam evaporation, photolithography, these type of things that you commonly find in a semiconductor fab lab.
Okay, thanks.
Thank you.
Absolutely. I think we have time for one more question if anyone has, otherwise we can move forward and onwards. All right, Katie, go right ahead.
Hi, Larry. Thanks for your presentation. I'm curious about your manufacturing facility. Is it one location? I think at one point I saw that it was additive manufacturing. So is it portable? And can you talk about where that is as far as what kind of capacity you are currently and where you hope to go in the next year or two?
Thank you, Katie. So yes, I apologize to you for not having a slide on that, but we have a full microfab capability. We have, a clean room. We have class 100 and class 1000 clean rooms. We have our own ceramic printed 3D printed capability. We have a lot of additive manufacturing, sputtering, electroplating, e-beam evaporation, PECVD, these type of things. And it's all in our Salt Lake City, Utah facility. We have a facility that's 36,500 square feet of both R&D and manufacturing and testing, of course. And in there we have again our class 100 and class 1000 clean rooms. So we do it all internally right now for the manufacturing. It is something that could be transportable to other locations. The equipment we have is not necessarily totally unique. It's based on equipment used for, again, manufacturing of semiconductors. So any modern fab could fab our devices. Yeah, our capacity, we're growing right now. The Air Force Works is helping us with doing that by, funding us to be able to manufacture, quite a large number of these in a batch process type of manufacturing format. So it'd be more automated, more in lines with, conventional semiconductor manufacturing.
Perfect. Awesome. That's all the time we have. I'll be the broken record that I am, and I'll tell you, Larry, leave your contact information in the chat so that folks can reach out. But pleasure having the presentation, and yeah, it seems like there's some interest there. All right, next up, Frank, are you able to present?
Yes, I am. Can you hear me?
Yep, let's get it going. Perfect timing.
So I'm in a cab right now, so I hope it's gonna be okay with the connection. Yeah, so let me tell you a bit about SkyMapper. SkyMapper aims to map all the sky all the time by building a decentralized network of telescope and all sky cameras that will allow our customers to request observation. Apply that. This is a project we started this year with my co-founder, Stefan Barvat. I'm myself an astronomer and also entrepreneur. This is my second company. The first one, Unistellar, was basically a company to develop, is still a company to develop digital telescopes, and we have sold 17,000 of them. Stefan is in the Web3 networking and data storage. We hire this year Guillermo Cid, our CTO, which is the master of infrastructure using blockchain technology. And finally, we have Tom Esposito, who is our chief science officer and the scientist of the group with me. So the main reason we created SkyMapper is to address the issue of space situational awareness, but also airspace protection. Recent events in the world show that we have a need for observing the sky all the time, observing satellites because they're growing in number. They are very serious assets in self-defense and surveillance, and they're being targeted as well, but also be able to observe drones, missiles, different parts of the world to basically protect and monitor the activity along specific sensitive areas such as border and other places. The growth in the space of economy suggests that we're going to reach $2 trillion in the next 5 years. So this market implies there is a lot of new partners coming as well. New company launching satellites and rockets, and so
I think we can't really hear you anymore, Frank. Frank, you there?
Yep.
Okay, perfect. Oh, was that Brian?
Yeah, that's me. Yeah.
Okay, I think we're gonna come back to Frank. If that makes sense, or if that works, because it seems like he's completely cut off now. Okay. So with that, I think we're gonna move forward to Hybron. Jacob, you want to go right ahead?
Yeah, sure, why not?
Thank you. I appreciate it.
Of course. Stand by. Let me just pull it up real quick. I want to say good afternoon, everyone. As I'm pulling this up, my name is Jacob Minima. I'm the Manager of Business Development over at Hybron. And let me just share screen. There we go. Hope everyone can see this. This is our, we created a little technology and space overview just for everyone here. Moving into, oh, excuse me. There we go. Anyways, Hybron was founded about 2 years ago by our founder and co-founder, Brennan and Aaron, out of Stanford and Berkeley. Together, they've got about 10 years experience in composites, now a couple more, some patents granted and pending. And they came from the race car engine world where they were building composite racing parts that went into racing motorcycles and race cars. So they've really brought a lot of composite experience in, and then they wanted to make their own sort of new manufacturing process of composites. Along with them, we've got Craig Ellis. Craig Ellis is our principal engineer. He was the director of composites manufacturing for the B-2 bomber. He's a former CTO of Northrop Grumman. We've got Zach, who comes to us from Joby. He was at SpaceX before. He's won and managed over $75 million of government contracts. And then Chris Young, who's our senior engineer, who's got about 30 years of experience with composites. Just on to our advisors really quick. We've got Bill Bender, who's also an angel investor in us. He's the former U.S. Air Force CIO, and he's really opened a lot of doors for us in the government, along with Jack Barron, who had a $2.3 billion exit. He's our advisor and an investor. So moving on to what we're really doing as a company. So right now, our adversaries are controlling all our raw mineral supplies. And this is specific for defense, right? So aluminum, you've got aluminum is almost 100%, antimony is 100%, titanium is almost there. With our composites, as anyone in the composite industry knows, we can we can source a lot of composites here in the United States. So we're very proud that everything we use is sourced here in the United States. In fact, the recent tariffs have done nothing to our prices at all, and haven't raised by a cent. So to go into just artillery shell production, and I'll touch on this a bit later as well, antimony is used in essentially every single artillery shell that the United States and the Western world create. 90% of it is controlled by China and Russia, and then China, Russia, and then Tajikistan is part of that because they're such a heavy Chinese and Russian ally. So what it really means is when we go to the next war and we're fighting artillery on artillery, if we're fighting metal on metal, there's just no possibility that we can win. With China controlling 50% of the world's steel supply and most of the antimony, we can't beat them in artillery. It just won't happen. Specifically right now, Russia's making $4.5 million shells a year, and we're making maybe 20% of that on a good month when factories are working. Going into composites, I said, don't worry, I'll touch on the artillery shells again here in a bit. We already use composites, right? They're lighter, they're stronger, they're more corrosion resistant, leading to increased performance, increased fuel and energy savings, and slashed emissions. The problem with modern composite manufacturing is that it's not scalable. It is one by one layers. It's extremely slow. It's extremely expensive, and you can't produce complex geometries. So because of the high cost, we're now looking and going into the companies are still choosing metal. Even brand new companies that are starting off making very lightweight munitions are going to titanium because composites just aren't an option currently. So what we've done is we've made a new manufacturing process. So we're essentially like we've got products, but at the core, we're a composites manufacturing company, and we just manufacture the composites differently. So we've got 10-minute automatable part production, where traditional manufacturing takes hours or days. No debulking, no trimming, no thickness control. Reduce labor and capital costs. So our main competitor material-wise is steel. We did a study that for steel artillery shell production, we are 40 times cheaper to set up production as our CapEx. We did a study to break even with titanium parts, so more than 50 titanium parts, and we break even with the capital expenses. We're 5 times cheaper than titanium at scale, and we break even with aluminum at 1,000 parts. Moving on, this is how our company started with making these compressor blades, and we actually had the world's first compressor blade that went into a GE fighter jet engine. So you can see our blades in here. So these blades, the tips reached Mach 0.9. They are the same size and complete dimensions of the steel compressor blade. Number 4 is the first blade that we put in. Works no problem. There was no issues with it, no vibration issues. Once again, 5 times lighter than the steel component. And then a big problem with compressor blades is if you've got a nick on the bottom 1/3, so if you look over to the right on number 16, if you've got a nick at the bottom 1/3 of your airfoil, you generally have to throw the blade away. So what we did is we ground down the bottom 1/3 and we removed a lot of material from that. And we threw it back in the GE J79 jet engine. The engineers said, okay, cool, we're going to wait out and we'll start the machine, but we're going to wait out in the parking lot because we don't know if this is going to explode. Went through about 20 minutes of testing, speeding up, slowing down, max power, and the blade worked wonderfully. So to kind of go over our technology overview to show you how we do this, first I want to start with traditional manufacturing because a lot of people just don't know. So first, you've got to take your fiber tow and you've got to weave it into fabric. On top of that, you've got to take your resin and you've got to pre-impregnate your fabric. That right there is 3 to 5 times the cost of just the material. You've already, 3, 4x the cost of it just by doing this process. Then you've got to cut out precision plies, which means you've got waste. Then you've got to lay down your plies one by one, vacuum bag them, hot vacuum debulk them, and then if you need greater thickness, you've got to go through the process over and over and over again. And then you've got to stick them in an autoclave to cure for hours and hours or days if it's a big part. After that, you've got to hand remove it. And as anyone who's done traditional composite manufacturing knows, all the edges are going to be sharp and jagged, and hand removing them is a tedious process. We've got to trim all the edges off, which is some more waste. And then you've got, if you need to really control thickness, you've got to machine the top surface for thickness control. So all in all, a very labor intensive, very expensive process with large machines that are, that are hard to get and very expensive. So what we do, and I apologize for this because I get the same questions every single time about how exactly we do this. It is a proprietary process where we're not sharing much. However, if you would like to talk after, we can get an NDA on, we can show you exactly how we're doing this. But essentially, we're taking the raw fiber and the resin. We are pre-impregnating it with our proprietary process that's also export controlled. We're combining continuous and chopped fiber into a mold, and we're molding it in a hydraulic press. After we mold it in the hydraulic press, the process takes about 15 minutes. We mechanically eject it, and no, we don't have to stick it in giant big autoclaves to cure or anything. the part is ready, warm to the touch. And I know everyone's going to have questions on this. Please, I've got my email at the end. Shoot me an email. If you know anything about composites, this whole concept seems kind of weird, but it's been something we've been developing for a couple of years. Moving back onto artillery shells. So artillery shells just happen to be our biggest focus. Thus far, as we received a 9-figure contract to deliver artillery shell casings. So going back to the 90s, the Army actually invented the world's first artillery, our composite artillery projectile. They spent a ton of money, and they wanted to lighten the force, reducing logistical constraints and increasing range and payload. They got to 19 successful live fires where the round worked, it could handle the pressures, it could do everything it needed. But essentially the Army came back to them and said, hey, how much did this cost again? It's not worth it. It's way too expensive. It's way too slow to produce. So they mothballed the entire project. The principal investigator for that project, James Bender, he retired shortly after he worked on the Excalibur and then retired. And then he's actually on our team now helping us develop our artillery shell. So our artillery shell looks a bit like this. The design has changed a whole bunch, and this is kind of our non-ITAR controlled design, where we are able to make an entire artillery shell out of composites and make it 5 times lighter than the steel. Because we've got that weight allowance now, we're able to put in more explosives, thermobaric effects, and position shrapnel so that you get max lethal area over what a standard Mike 795 high explosive artillery shell would get you. So we've got a lot of traction with this. Like I said, a 9-figure contract. We're working hand in hand with JPOAA. We start testing in January, February, March timeframe, starting out in Texas. We own the world's or America's third 155 millimeter bore and breech assembly that's in private hands, where we're going to be doing all of our testing. Now, I know I kind of went into the artillery shell aspect of all of this, but that is because it's our main product right now. But we are also working with JPO Aviation on drone bodies. We're working with the only prime I'm allowed to say is Northrop Grumman, where we're an approved supplier and we're working on some things for them. But also there's, in the end, no matter what our biggest product is, we are a composites manufacturing house, and we have a method of doing it that is far cheaper and far faster and much more scalable than regular composite manufacturing. So our space applications, we've worked on reentry cubes because our material can withstand high heat. We've worked on a whole plethora of things. But in the end, we're a composites material company, and anything that you're currently building with titanium or you're currently using steel for are things that we can replace with our composites. Even though there's 3 things right here, the list is really endless. We're doing anything from door hinges for the Navy to missile bodies for a prime, where once again, just focusing on the material aspects of it. For that, I want to thank you all for taking the time to listen to me speak about our composites. I'm very happy to take questions. Once again, any questions that revolve around the manufacturing side, I won't be able to talk too much about those. But please, if you are interested, shoot me an email and we can get an NDA sorted, and then we'll be able to give you a full proprietary brief. And with that, I'd like to open it up for some questions.
Lee, go right ahead.
Yeah, two quick questions, and I know we don't have much time. Thank you very much for your briefing. Do you have size limitations with your molds and with the products you produce? And the second, can you speak to any vulnerabilities, particularly with seams or integration with traditional materials, moisture absorption, maybe things like that?
Yeah, so very first question for size, great question. Right now we're limited not in size, but in tonnage with our presses. So our largest press is a 452 ton press, and that can get you about 9 by 9 inches of a material. That being said, we can iterate that over and over again. So right now our machine can make, think of the size of an artillery shell, a large one. We can make 10 of those artillery shells, the bodies for them, every 15 minutes. So even though the part size right now is small, we can do many of them at a time. And with a larger press, which we've got on back order, we'll be able to make great giant big parts for class 3 UAS and wing bodies for other aircraft. And then for your second question for limitations, so we can actually mold in metal inserts when we do our mold. We've done a bunch of testing and we're still doing testing. Each application is going to be something different, but we've had no problems with moisture or with corrosion or anything like that. In the end, we're using the same ingredients that go into like a sleek carbon fiber, like you see on the screen there. We're using the same elements. We're just putting them together in a different way to maintain all the strengths and make it mass producible.
Thank you.
I hope that answers your question.
Perfect.
Yes.
Bob, you're up.
Yeah, Jacob, thanks. Quick question on the Matrix. Did you develop the epoxy system yourself, or are you just procuring a system or a variety of systems and using it with your process?
Yeah, so we work hand in hand with our resin supplier who has created a specific resin for us to use. That being said, different applications require different strengths and different resins for heat and for everything else. But we've got a very good relationship with our resin supplier in order to tailor each one of our products to the specific purpose. But we did not develop it ourselves, no. We developed the manufacturing process.
Thank you.
You're welcome.
I think we have time for maybe one more question if anyone wants to go last. Otherwise, we'll keep the show on the road.
If there aren't any other questions, sorry, Asher. If there aren't
You're
any
good.
other questions, just for the investors in the audience, right now we have received a term sheet. We've got a lead. We are still looking for strategic investors. We'll be looking to close our round by the end of October, mid-November timeframe. And we're raising $20 million at a $90 to $130 million valuation as a seed round.
Awesome. Thank you so much for the presentation, Jacob. I already know that your email is all over the presentation. So if anyone wants to reach out to Jacob, I highly recommend they do. Highly recommended. And yeah, and I see that there's some questions in the chat about alternative materials that could be interesting to answer if you have the time. And yeah, with that, we'll continue onward and forward. Officially, we've moved in to the second session, and now we are going to, have a next batch of companies present. For all of the folks who are joining for the second session, specifically, we could either go around. Let me see. Let me check. Yeah, we could go around. Although I do think it's a very similar audience. So for those who have been here for the first session, the second session is going to be somewhat similar with some new people. For the second one, what we'll do is anyone who asks a question, please just quickly introduce yourself for the first time, and then we'll continue moving forward from there. With that, we're going to start off with AGC Power. If you want to, start sharing your screen, feel free. We are ready to go.
Good afternoon, guys. Let me just go full screen here. Hopefully, all of you can see my screen here.
Yep, it's great.
Good afternoon, guys. I'm Sumit Gandhi. I'm the CEO and founder of AGC Power. To give you just a quick brief, I'll be talking about beta voltaic batteries for space and defense application. But our goal has been to build dual use technologies too. We are affiliated to University of Chicago, and we are part of Northeast Microelectronics Hub, which is Department of Defense Hub. So let's talk about what exactly are we going to be presenting in terms of batteries. These beta voltaic batteries that I'll be talking about will be kilowatt scale batteries that can operate 10 to 30 years with no recharging. Now, why is that such a big deal? Because beta voltaic batteries typically don't yield kilowatt scale power output. When we talk about beta voltaic batteries, we talk in microwatt scale, not in kilowatt scale. So we are talking about these batteries that would be at least 100x more powerful. Now, we all know in terms of national security, the importance of batteries in drones, especially surveillance drones, superiority requires long duration batteries, need in energy storage, data centers, and AI. Even in space sensors, the importance of batteries that can long last. Actually, there are multiple aspects to it, not just the source of power, but also how the batteries are designed to last for that long. Let me see. So while I know this is space specific mission and RTGs are known in the space, but RTGs are not applicable for all applications. There's a middle ground that we are talking about here, where we don't need bulky, oversized RTGs, but we need high power output. We also are talking about dual use, so we are trying to avoid something like plutonium-238, which are used in RTGs. And that is where the beta voltaic battery offer that middle ground. For those who don't know about beta voltaics, these batteries use radioisotopes, nuclear radioisotopes, which emit only electrons. So they don't emit alpha or gamma particles, they only emit electrons. And then there is a semiconductor layer, which basically captures those electrons. Now, traditionally, these beta voltaic battery have very low efficiency. They operate between 1 to 5% efficiency. So because of that low efficiency, these have very low power output, which is what I was saying. They offer microwatt scale power output. And they also are susceptible to radiation damages. So if you want to build long duration kilowatt scale batteries, a lot needs to change here in these batteries. There are obviously other aspects, heat generation, fabrication challenges. So what did we guys do different then? Well, what we did was we used the concept of blue LED light. So those of you remember, the blue LED was developed by Dr. Suji Nakamura, and he was awarded a Nobel Prize for it because it was hard to do that. But what is very important about the semiconductor architecture that was built is what was very efficient. And we use the same concept to allow higher efficiency electron flow through our batteries, which means less of it is lost as heat. And so there are new materials that have been developed, like scandium aluminum nitride. So basically what we decided to focus was not just on one aspect of the battery, which actually requires multiple aspects. So we decided to focus both on radioactive isotope as well as the semiconductor for high performance and high longevity. And so the radioisotope that we are using is a hybrid source. And we use hybrid source because space may need different type of power output. Data centers and AI might need different applications. Even EV may need something. So every application is different. And so by having a hybrid radioisotope, we are able to customize the life of the battery and the power output of these batteries. So along with that, the semiconductor layer, which is mainly based on 3 nitrides, because 3 nitrides are what we call radiation hardened materials, that allows these batteries to last much longer. By the way, we have, I have 17 patents, 2 very specific to just this type of batteries. And we'll talk more about how we believe that we are going to make these batteries work. So talking in terms of the applications, right? When we go talk about kilowatt scale batteries that can last 10 years or 30 years, continuous operation, no recharging. Now we have much bigger range of applications where these batteries can go. Remote sensing satellites are obvious ones for space applications. For Department of Defense batteries, we can have built smaller batteries at 600 watt scales, as I mentioned. For other new class data centers also, and remote deployments where logistics can be an issue. So how do we know, like actually what we have been doing last year on these batteries is we partnered with University of Michigan. University of Michigan was working on some aspect of semiconductor layer that they were doing on their own, not in conjunction with us. We were building softwares to predict the performance of the semiconductor architecture that we chose for these batteries. So I don't think there are many softwares out there which can predict the performance of a beta voltaic battery. So we had to go and build our own softwares. That is how we came out with the kilowatt scale batteries. So our technology development roadmap here, again, I think the semiconductor layer needs to be optimized more for different radioisotopes. We'll probably have to partner with Argonne National Lab, mount the radioisotopes and test the performance, and then add some of the peripheral components to improve the efficiency of these batteries. So if you're again wondering where exactly do these batteries stand right now, those are mostly in the simulation world. We have tested in simulation world, and some aspect of semiconductor has been developed. So we have not fully developed the battery. Just for clarity, there needs to be another year and a half worth of work on these batteries. But I think the duration from now to the commercialization of these batteries is relatively still very short. We would love to partner, by the way, with defense contractors like Lockheed Martin, Siemens, Raytheon to take this at a commercial scale. And because the semiconductor layer that we are talking, it's so nuanced, it's almost like meeting the best semiconductor chip in the world to get these batteries to perform the way it is. So just in terms of competitive advantage, I think City Labs offers these type of batteries. They offer at 0.5 microwatt per centimeter square. NASA has somewhere around 2.4 microwatt per centimeter square. We believe we can be between 240 to 500 microwatt per centimeter square on the high end. So as we are talking kilowatt scale, I think our SAM is a much broader market rather than just focusing on beta voltaics. I think even if we choose 5% commercial with Department of Defense, talking around $1.9 billion of market here. Our go-to-market strategies again start with very specifically defense, then enter into a mixed use grid energy storage and data centers, and then go into the EV market if needed. Like so, to target defense is our first priority here. Again, we are ideally looking for 3.2 million pre-seed. I think this we can get and deliver the performance of these batteries very quickly. Little bit about myself. I have over, as I mentioned, over 17 patents pending. I have background in fuel cell, semiconductor, silicon. I've also been in other specialty chemical industries. And my partners, Frank Chimbole and Karthik, also have experience in the fuel cell and battery space. With that, I'll conclude my presentation and open for questions out here.
Absolutely. Thank you, Sumit.
Sure.
All right. Floor is open for questions. Whoever wants to get it started. Someone in the chat. Sure. Who was speaking? Go right ahead.
Yeah, that was me, Todd. Principal here at Mark Ventures. Just curious, when you talk about defense, which part of defense are you targeting? Who's your beachhead customer?
So we actually anticipated for grid energy storage applications and forward deployment of these batteries, where diesel logistics is an issue. That is what we were anticipating. The second market is also the drone market, because these are only electron emitting radioisotopes. They are not harmful in other sense. So these two are our main beachhead market.
Got it. Thanks.
Go right ahead, Lee.
So I'm wondering, it sounds very compelling, but I'm wondering, kind of in the same spirit as the last question, as I look at defense and a lot of the shifting priorities and the shifting investment and the change in programs on the R&D side, and knowing this still needs a bit of development left, you said, I think about a year and a half. wouldn't commercial markets possibly, or others in the energy space, maybe be more attractive relative to adopting something as early adopters to help you advance this more quickly? And once it's proven out and in play, then maybe defense. I just toss that out for consideration.
No, thank you for doing that. I think where we were wondering was the Nuclear Regulatory Commission licensing aspect for civilian use might be more challenging compared to defense. That is why we were prioritizing the defense applications more than the civilian. But as I mentioned, these are electron emitting, and data centers AI boom could really be driving these type of battery demand.
David, go right ahead.
Hey, good afternoon. David Canada from the Boeing Company. I lead strategic sourcing partnerships, and I guess my question is centered around, with you having a focus on the defense sector and understanding the current and ongoing challenges around rare earth metals and elements and how that impacts semiconductors. How are you taking all of that in consideration for your next, say, 18 to 24 months of development?
Yeah, no, that's again a very good question. I think the need here on the semiconductor is more specific to the end application. If we are looking specifically at critical and mineral application, and let's say we talk about grid space, then there is a different type of product that can be utilized that we also have, which we have focused on, which is called composite metal air battery, which requires no fancy rare earth metals there. So it's an application driven aspect. In this case, we do unfortunately use gallium nitride and 3 nitrides, but the purpose is to make sure it is radiation hardened and it can last longer there. And so there are very few rare earth materials that we can use here in this case.
Absolutely. Perfect. And one person asked in the chat, just this will be the last question, if it's been field tested at all.
No, it has not been field tested yet.
Okay. Awesome. Thank you so much for the present, Sumit. That was really great. Feel free to leave your contact information for folks to reach out to.
Thank you.
Absolutely. Next up, we have Pi Logic. Feel free to start sharing your screen whenever you are ready. All right, perfect.
Here we go. I don't know if anybody is here at the Stanford DevCon event at Stanford, but I've just snuck into one of the Stanford classrooms. So I'm going to give my lecture in a Stanford classroom, which is quite fun.
That's fun.
So Pi Logic, a little bit about the background. It's founded on the PhD work of Mark Shavira. He was at Raytheon 12 years and was looking at radar, was looking at autonomy, diagnostics, and machine learning didn't work very well because you didn't have data on all of the edge cases and rules were pretty brittle. And so he became very interested in reasoning engines and probabilistic inference. So got his PhD at UCLA under Yuta Pearl, who invented Bayes nets, which is one of the types of causal model that we use. And then Google kind of took him away from Raytheon. They paid him 10 times as much. He went and ran their Google Ads group for display ads, which turns out is a huge Bayes net, one of the biggest Bayes nets. And so what is it that Pi Logic is focused on? We are focused on really critical decision making where you need explainability, you need to be able to set rules and sensitivities without perturbing the rest of the model. We're focused on use cases where there's not a lot of training data, and so LLMs and machine learning more generally don't work well. We've raised a 4 million seed, led by Scout Ventures and Seraphim Space, team of 5, and we have 2 models that are sort of at the TRL 5, starting to work with AFRL, RVE, so with Joseph Melville in Albuquerque. And now I'll take you through just sort of a taste of what we're doing. So there's some things where precision doesn't matter, and then there are things where precision matters a lot, whether that's life and death, or whether that's losing a satellite or making decisions on billions of dollars of infrastructure. You really want guardrails around that, and you want to be certain around that. And so those are the use cases that we're working on. Two models, self-diagnosis and remediation, first of satellites, but now starting to look at other things, like we've looked at the V-22 Osprey self-diagnosis, and radar. So the goal of being able to track 1,000 drones, even if there's 90% noise in the system. So replacing the Kalman filter with something that both has physics models in it and understands and can change its belief on the past, where a lot of radar systems are really focused on, because they're real time, trying to focus on just the moment. So those are the two models that we currently have on top of that inference engine that we've built for ourselves. Now, the main problem with running inference and these types of models has been something called tree width. And so sort of classical AI breaks down, that's the black line that's exponential, time and space exponential to tree width. So that means that if you present something with thousands or tens of thousands of edges, you run out of RAM, you run out of memory, you can't do it. And so for some problems, the types of problems that we focused on, we've been able to break that. And we're able to break that where there is logical determinism and where you can sort of simplify that graph. And I'll just give you a couple technical slides to give you a taste of that. So the first barrier is it's really hard to build Bayesian models, causal models. It's hard to model it correctly, and it's hard to model it susceptible for inference. So we've built a descriptive language, in this case for electrical systems, where our customer, like Astranis, they can load a JSON file or load a file and say, these are my 4,000 components, this is how they're laid out, these are the relationships, and that automatically builds the model. So what we're trying to do is provide tools to engineers to make it really easy to onboard the model production part of it. So that's kind of the first step, is make it easy to build the model. This is the most technical graph. Two insights here. The first one is take that BayesNet and use logic solvers to simplify that. So if you think back to algebra, that's a little bit like factoring. So find where you can increase the exponent, find zeros where you can cut parts of the algebraic equation. So we've found really novel ways to do this, and to do this in an automated way. And then the second thing is pre-deployment, turn that BayesNet into what's called an arithmetic circuit, which is on the bottom left. And what that means is that you just have addition and multiplication, and now you can run very, very advanced inference on a microprocessor, on a satellite, or a very simple CPU on a drone with very, very low power, and you don't need a lot of training data. So now suddenly you can have a model that's much more accurate, not a lot of training data, and you can push it to a satellite or push it to a very low swap environment. We have Astranis and NASA as kind of the pilot customers on the self-diagnosis and remediation of satellites. And we have Air Force Research Labs, Riverside Research, and several others on both radar and the diagnostics. So still pre-revenue, but we have about 2 million that we think we'll get in Q1 through some of the SBIR and some of the awards that we'll get on top of our CRADA, which is free. It's unpaid with AFRL RVE, but we can add, we have folks at DARPA who are interested in that. We have people from the SOF community that are interested in adding money on top of that. A little bit what it looks like. So the Kalman filter, here we're looking at rocket trajectories. Our models are non-ITAR. This is synthetic data. When we give it to Riverside or give it to one of our customers, it becomes ITAR when the secret and top secret data is put through it. Again, an advantage of not being machine built or data built is we can build that reasoning model, let our customers put the qualified data in. So being able to track much more clearly, again, the goal of being able to track thousands of things, we expect to be able to do thousands of things early next year. Right now we're less than that, but we do it much, much more clearly than the Kalman filter. So again, no hallucinations. It's not machine learned. It's between 1,000 and 10,000 times faster for many of the use cases. Can run it on GovCloud or at the edge. And then these are our investors in my contact. So happy to take any questions. Thank you.
Perfect. Thank you, John. All right, opening up the floor. Feel free to start asking whenever you'd like.
Brandon, good to see you.
Animal Eye has a question, but he's in the audience. Do you want to put it in the chat? Oh, he asked, is this a complementary to LLM or is it a replacement for it? How do you train the model?
So most of the model is not trained. So it understands the physics of how things move in space, or you upload all of your components of your satellite and it reads it. Some people want to use LLMs to query a reasoning engine like ours. So it's either separate or it can be queried by the LLM. We think LLMs are really good at language, really good at finding patterns. We're focused on very niche applications where ML and LLMs don't work very well.
Got it. All right, Lee, you're up.
Yeah, this is really fascinating and extremely, mind-blowing. Can you speak quickly to the transferability in other arenas that you don't want machine learning to fuel your AI and that transferability to other complex challenges?
Yep. So we're looking at advanced decision making for logistics. We're looking at power grids. We're looking at oil and gas compression. It takes about 2 or 3 months to build a template model for a new industry. We need industry specialists. We need like real use cases, real data, real things to work on. And then the second customer takes maybe 2 months. And then after that, onboarding should be small number of weeks. So to take on a new problem, a couple things. We need enough of a specialist who knows the domain. There has to be some determinism in that system. So there have to be rules or mutually exclusive things. Like in logistics, certain things can't happen before other things happen, or if one thing happens, other things can't happen. So there has to be some sort of logical structure in the type of problem. And then it takes about 2 to 3 months to build a model template for that. And then that's more broadly addressable for that category of problem.
Yeah, thank you. That makes sense. Thank you.
Perfect. Cassandra, you're up.
Hey, thank you for the presentation. And I didn't get a chance to introduce myself earlier. Cassandra Carruthers, managing partner of Departure Capital, a Bay Area-based VC firm focused on frontier tech for resilience, critical industrial infrastructure, mostly. A little bit of overlap with Lee's question. I was curious specifically in aerospace, where are you going, if anywhere, deeper or beyond radar diagnostics and sensor fusion? And then a partial follow-up question to your last points about the onboarding time and expertise needed to get into these new either spaces or further even into aerospace and defense. How do you maintain a competitive moat for the long term? Thank you.
Yep, sure. So after radar, we're doing electrical and power diagnostics. So Astranis, we're working on their geo satellites, and they've lost 2 of them. They want to be able to automatically sort of do a root cause analysis and remediate. So we're doing that. We've done some of that with the V-22 Osprey. Again, trying to predict hard clutch engagement and like to land before that or to remediate that before that. The moat is really the being able to scale Bayesian inference and run it at the edge. So it's 2 moats. One is you have to be able to solve much harder problems than have been solved until my co-founder's thesis in 2008. And then that just solving it isn't enough. You have to be able to solve it in milliseconds or in tens of milliseconds and without GPU on very simple hardware. So the moat is really being able to solve that complexity and do it quickly. Part of that 2 to 3 months of building a model is coming up with a descriptive language. So for instance, with Astranis, they had some new components that we had never seen before. We had to add that to the component library. But now if Astranis wants to change their layout, they can load that right away. The other thing is we're working with SIFT with Astranis, where it talks with Nominal. So really we want to go to the people that are helping people build hardware and be able to extract, this is the layout of the system, directly from a SIFT or directly from a nominal, and fit into the workflow that our customers have. And that, again, makes the onboarding much less expensive on their time. It's like, okay, well, what format are you using at the moment? Then we need to make some changes to be able to read that, and then they can start running the model.
Perfect. Thank you for that. I think that's the time we have, Joanna. So thank you for the presentation, and feel free to leave your contact information in the chat.
Yeah.
Awesome. And for the I believe it's one of the last presentations, we have G-Space presenting. Feel free to get going whenever you are ready.
Can you hear me?
Yep.
Hi. Okay. Is there a lot of noise or it's pretty good?
Nope, it's pretty
Okay,
good.
okay, good. Okay. So, oh, and I see that you're sharing my screen. Thank you so much. Apologies. I am in Berlin, actually. I'm at a conference dinner. I try to step out and have the best signal I can, but thanks so much for the opportunity to being here. I'm Ioana Cosmuța, founder and CEO of G-Space. I'm a serial entrepreneur who left NASA to pursue space manufacturing. I didn't just predict this revolution a decade ago. I helped design it. Can you move to the next slide, please? There's tremendous trust powering the future of manufacturing today in semiconductors, pharma, and biotech. Companies such as Merck, Eli Lilly, Mitsubishi are going to space for innovation. However, hundreds of millions are wasted on trial and error flights. The industry needs now terrestrial commercial design tools for optimization. Next slide. I've bootstrapped G-Space, secured $1.2 million in non-dilutive funding from grants across NASA and NSF. And we had 10 customers who paid proof of concepts project with us in the amount of $800,000. We just launched our MVP to kick off the company expansion in this rapidly growing market. Next slide. Artificial retina is one of those 10 customers. Space is the only way they can achieve manufacturing quality and yield. Working with us, they optimize the process for potential $10 million in savings. The same applies to fiber optics, advanced materials, tissue chips, organoids, stem cells, etc. What I want to add here also is that from a national security perspective, microgravity manufacturing may be a significant player in helping reduce or remove reliance on rare earths in advanced materials. Next slide. G-Space offers the first commercial machine learning powered software platform to simulate products on Earth before going to space. NASA features us on their website. Our customers design 10 times faster and at half the cost. Your investment is not in rockets or space infrastructure. It is in SaaS in a rapidly growing market. Next slide. Dassault, Autodesk, ANSYS dominate CAD, but none can design without gravity. That's our moat. We have the largest microgravity database, a combination of public and private sources. We have patented IP that's active both in the US and in Europe. We have the first mover advantage, and we have domain expertise. These players could be potential partners or acquirers. Next slide. I've recruited a uniquely experienced and business-savvy team to power our growth and scale into a unicorn in this market. Next slide. Our business model is standard B2B SaaS, and our licenses are coming from individual to enterprise. The annual subscriptions range from $3,000 to $150,000. We recently closed a $165,000 contract, and we can ramp revenue significantly by converting more clients at these prices. Next slide. Our current pipeline includes active conversations with big names such as Mitsubishi, Bristol Myers Squibb, 3M. We can convert our LOIs into $5 to $10 million in contracts in the next 24 to 36 months. Next slide. In the past, we graduated from the Seraphim Accelerator, and we just graduated from the Blue Startups Accelerator, who also made an investment in us as a pre-seed. And building on that, we are actually closing our small $250K pre-seed round and opening our round for $4 million. So we're looking for a price round with a lead investor. We have been in conversation with several potential leads, but we're looking for a lead investor that would write a check of $2 million. So strategically as well. And this would help us convert these proof of concepts into enterprise deals. We could we accelerate our sales, scale the enterprise deals, and reach $1 million in annual recurring revenue in the next 12 months. The hockey stick is right in front of you. Next slide. If you want to be part of scaling space manufacturing, join us. G-Space makes it possible and profitable.
Perfect. Thank you, Iona. Feel free to open up the floor for questions. Whoever has a question, feel free to ask. I could get started then. I have a few questions. So I've heard previously about, fiber optic cables being produced in space and having less imperfections due to that. What would you say is like the highest value next thing for in terms of like microgravity manufacturing?
Yeah. So in my opinion, it's high magnetic materials. That's where also that it's one of the strongest candidates for also reducing or removing rare earth dependence in achieving high grade magnets. And then also battery materials as well as graphene and diamond.
Nice.
So these are a couple of materials across which we're working today.
That makes sense. And then in terms of the I know you mentioned NASA and the NSF in terms of grants. Have you pursued DoD grants as well?
No, I have not. And actually, sorry, I forgot to ask about that, but that's one of the areas where if there are specific calls or interesting partnerships to pursue this, that's definitely one area that we started to look into. But our goal to date was to secure the patent, to release the MVP, right? So we have the platform out, we're onboarding customers, users. And so, yeah, now we can try to expand into the DoD side of things. Like I said, especially the rare earth dependence. I think that's a really significant aspect of microgravity manufacturing that has not been explored in the past.
Lee, go right ahead.
Yeah, thank you. Very interesting. I've been talking to some companies, and a couple are interested in space manufacturing in space, particularly for pharma applications. Can you speak to that?
Yeah, to a certain extent. So we do have customers in that area. I cannot tell you specifically what they're looking for, but it's in protein crystals. There's a lot of small molecule crystallization, monoclonal antibodies. I mean, I already mentioned Redwire and Bristol Myers Squibb, but so those are the ones that we also have LOIs from, or we're about to onboard them as users on our platform. Did you have more specific questions?
No, I was actually really curious if anything is beginning to be in play in application where you have some data to show results. Only because I'm seeing others emerge and thinking this is a competitive field already. So
it is, yeah.
Yeah.
And then, yeah, the other one that I forgot to mention is tissue on a chips and organoids. So
okay.
We have from our database, we have data all across these applications. That's what we've been curating for the past couple of years. So it's the largest database. The reason what we're doing, what's very important that we do today is we set as a criteria for success in manufacturing and moving fast from application to scaling up is the quantification of the microgravity impact and the standardization of the tools that we use in order to quantify that. There's been a lot of trial and error, and from every flight, the return of valuable data has been unfortunately pretty low. So we've like I said, we've went through over 100 terabytes of previous microgravity experiments, extensive campaigns. I'll just give an example of one that's public. So for example, dusty plasma experiments, which underlie advanced manufacturing physics. It's 8 campaigns and it's like 95 gigabytes of data, right? And out of that 95 gigabytes of data, maybe we can extract what's really valuable, 20%, unfortunately. And so that's why putting, especially for space manufacturing, putting this measure first and also using these algorithms to monitor and capture this information in real time in space, it's transformative to really accelerate and scale up the potential of microgravity manufacturing.
Thank you.
Perfect. I think that's the time we have, Iona, but thank you so much for the presentation.
Thank you.
Feel free to leave your contact information. Thank you
I
for
will
joining
put it
us.
in the chat. Sure. Thank you. I'm glad the connection worked. Thank you so much.
It worked. All right. Speaking of connection, Frank, you want to give it another try?
Yes, I'm here. Hello, everybody.
Hello. Let's see if it works.
I'm at the airport now, so let's see. It's gonna be better. Should I
Let's do
start
it.
from scratch or should I just show?
Let's start from scratch. I don't think most of the
alright.
people here now have
Great.
seen it yet.
Okay, so you should be seeing my slides. SkyMapper. We are aiming to map all the sky all the time by building a decentralized network of telescopes, all sky camera. And the point here is the decentralization on the Web3 provide resilience and also traceability. So you can trust the data coming from our platform. To build this project that we started last year, basically we partnered with my co-founder, Stefan Vervat. Stefan is the blockchain guy. He has been working in this technology on the Web3 for data storage for multiple years. And I'm myself, astronomer, entrepreneur, developed multiple companies. One of them is called Unistellar. We have created the first digital robotic telescopes, and you will see that it's a partner of this project as well. I'm a researcher, so I built instruments on very large telescope in Hawaii, VLT, Chile, etc. Talking about Chile, our CTO is from Chile. He joined us this year. He's the master for the infrastructure. He's been developing the infrastructure, and we finalized our MVP quite recently, a week ago. And join us as well, Tom Esposito, who has been working with me for 10 years, and he's the astronomer, the scientist of the group. He's basically developing all the data processing, data analysis that we need with his team. So space is becoming an interesting market. First, we're probably reaching $2 trillion in 5 years for the space economy. We're talking about new partners, new people coming, joining the space race, and launching satellite as well, but also with a need to do some surveillance of their own satellite. We expect that there will be more than 50,000 satellites in orbit around Earth in 2031. We have around 10,000 at the moment, and 10 years ago we only have 1,000. So the satellite infrastructure is growing in numbers, but it's also growing in terms of vulnerability. We've seen recent events where satellites being listened to, followed by other nations. So it's becoming an asset into our defense system. That's one of the reasons the large large defense plan, such as the Golden Dome and the Rearm Europe plan, both have a large contribution for space into the budget. So we are proposing to become basically the network that will be capable of providing observation of the sky, satellites, but also drones, using network of telescopes and all sky camera. So we have partnered with SETI Institute, a scientific institution here in the US. Unistellar is a French-based company that develop telescopes and offer access to the telescope to kickstart our project. And we have also partnership with other large observatories, such as in Canary Island and in Europe. And the goal is to grow from 50 stations, telescopes, in 2 weeks to 1,000 by mid-2026. We already have established our network. I can show you with 14 telescopes connected. The use of blockchain is truly necessary here to provide, as I mentioned, resilience, integrity, and make sure that we can trust the data. We have 2 verticals in our company. One, we do science, so research, outreach, and so on, but we also have a very strong defense and industry component to address the issue of security, efficiency, and offer innovations such as AI-based algorithm to follow satellites. And we are tended to be as in compliance and support EU, NATO nations at the moment. We start in conversation with a large number of corporations in Europe and the United States. We have our first contract to monitor satellite with VCLU, the Czech Space Research Institute. We're discussing at the moment an MOU with Thales to be integrated in there and to have access to their ecosystem. We're also discussing with other SSC companies such as Aldoria, Lookup, and Biolabs. In terms of performance for satellites, you're gonna see a video on the bottom here. This tiny dot moving is basically a Cosmos 2553 observed from Maryland by one of the citizen astronomers who run a unistellar telescope. So we have been running multiple experiments. We have a network. The unistellar network, as I mentioned, is 3,000 active citizen astronomers. They do not are yet on our SkyMapper platform, but they can do the same type of observation manually. The main difference here is that the SkyMapper platform will do the observation automatically, meaning that people will just have to put the telescope outside, and we will take control and we will do the observation and collect the data and send the data to our platform. Despite the difficulty of having people doing this manually, we get 11,000 observations in 2024 of any type of observation, meaning astronomy, but also satellite and so on. So we expect in the next 3 months to collect 100,000 observations. We have our network. Running simulations based on the properties of our network, with distributions and so on, we know that we can observe in 3 days all the Starlink with only 300 stations, which is 100 times faster than our competitors, which has generally less than 25 stations. We also have a very good accuracy because we can combine observation at the same time from multiple telescopes, so we can reach an accuracy better than 5 meters on the position of low Earth orbit satellites. And then we can scale. We can scale because we have a pool of 17,000 unistellar telescopes which are waiting to be connected to our platform. We reward the people in token, and this token will be later on convertible in fiat money. So people will have an incentive to join our network, a financial incentive. So here we are. We have developed the SkyBridge in less than 6 months, which is a device that connects any telescope from Unistellar to our platform. So opening the pool of potential observers to up to 17,000 telescopes. We're starting selling the SkyBridge and the telescopes on our website. We are developing accessories such as the SkyPod that will allow people to have the telescope basically fully autonomous and self-sustained nearby their house. And we are opening a new type of instrument with the all-sky camera that can observe as well drones, satellite entries, meteors, and also hypersonic missiles. We're doing some tests at the moment. I'm going to show you briefly the Sky Viewer. It's basically our interface. It's been running now for multiple weeks. We are beta testing phase. We have, as I mentioned, 17 telescopes connected. Here you can see a user, I think he's in Washington, DC, controlling a telescope in Finland and start acquiring data. So in this case, we'll take observation of an asteroid, of a beautiful body in space, a Messier object for those who wants to know. You see the telescope moving. And as I'm talking, if you look at the screen, you will see that suddenly he's gonna find the object that we requested and start acquiring data. And after acquiring a few frames, the image will get better and the data will be then sent on-chain onto our server. So we have done the MVP. This was really the goal of our 6 months MVP after our pre-seed round. We raised $3 million US with 3 VCs for this project. Now we expanded with the SkySphere, so an all-sky camera, and that will be also on chain and will be also connected to the SkyBridge of the equivalent, and we have some intelligence on board. We have done some tests and we have shown that this super cheap instrument, costs typically $150 US, could be maintained by thousands of people on this planet, and we'll be able to observe drones, detect drones, but also detect any type of activity in the sky, airplane, and so on. So we considering the context actually in Europe, especially, we are being approached by Finland and also in North America by people in Canada to test this SkySphere in extreme environment, so we can start building a network in the Arctic specifically and across borders of specific country. So there's a goal of our seed round, which is a strategic round, is to accelerate this development. We have a partner, as I mentioned. Thales is going to be a strong partner of SkyMapper. We are opening subsidiaries in Europe to be able to work with European companies and government over there. In the industry, we have the Unistellar to manufacture telescope, Explore Scientific to distribute telescope, Akave to store our data, and Neo NextDome for the building of accessories. Those are relationships that we solidify and we started working. We have contract as well with those entities.
1 minute warning.
That's my last slide. That's perfect.
Perfect.
We're very ambitious, but we have been ambitious for MVP, so we continue to be ambitious for the next year and a half. The goal is to have by June 2026, 1,000 telescopes connected to our platform. Unistellar telescope, so small aperture telescope. We're talking about typically 11 centimeters, for instance, but they're capable of detecting 95% of low Earth orbit. But we're also putting now together large telescope, 1-2 meter telescope. There is 100 of them in the US only, which are barely used. So this will be kind of a way to connect those telescopes and be able to do space situational awareness with high quality data, traceable, immutable, and a network which is resilient. And that's the main point here. If something happened in California, an earthquake or major outage, our network will continue to work. That's the power of the Web3, and that's to provide this decentralization that allow to have a system that is sustainable. So extremely useful for a partner in defense and surveillance, but also commercial entities. You don't want to hear that you lost your billion-dollar satellites because there was a power outage in California, for instance. So we are a solution And we believe that this is the way the future will work with this decentralization. If you want to join us, you have my contact information here. You can follow us on social media as well to hear more about our activity. Thank you very much. Appreciate it.
Absolutely. Opening up the floor for questions. Feel free to ask. Lee, go right ahead.
Great presentation, Frank. I very much enjoyed it. What I take away from this is you have the ability to bring together, integrate lots and lots of data with speed and accuracy. Phenomenal in and of itself. And now to turn that data into intelligence and insight to make sense of it. I sense on that chart where you showed all the components that API plus AI agent is key to that. Can you speak to that piece of what you bring together?
That's an excellent question. Yeah, I forgot to mention this. That's perfect. So our seed round is really to accelerate this part, this component of our network. It's crucial that we make a sense of the data we're gonna collect. We're gonna collect 100,000 observations of satellites. So we are starting having tools to do, for instance, orbits almost in real time. But now we need to hire AI focus engineers and also researchers to help us making sense of this data. So for instance, be able to detect when there is a close approach between satellites before we even understand it's going to happen by looking at multiple orbits, for instance, and the way the orbit varies over time, we'll be able to predict this kind of event and can alert the user if there is a close approach or something happening as well. For drones, the reason we want to accelerate the project and have stations right now available in Finland, in the Arctic, but also in Canada, it's because we want to start acquiring a large amount of data and to train our algorithm. So we want to deploy 20 at least stations this winter to see if they can survive the Arctic winter, but also if we can record observation continuously. And when we hire this team of researchers, we'll be able to train a very complex but also smart algorithm to see the difference between a drone, a bird, an airplane, or something else flying in the sky.
Thank you. Thank you.
We have time for one last question. Anyone wants to jump in? Otherwise, I can jump in. And can you talk about some of your other traction and use cases?
Yeah. So we have been discussing with, so I mentioned SSA, other SSA companies, but also with satellite companies that launch satellites. And one of the reasons is because they want to have an independent partner to be able to do what they call LEOP. So LEOP is when they send a spacecraft in the swarm of satellites. You need to be able to identify quickly where is your satellite, and it's not always possible if you don't have the right ground stations. So we'll be the eyes that basically be able to do this. So we're being approached by Tendeg, Adlix, which is a company that launched satellites from India and Saudi Arabia, to become the partner for this launch. And we're also talking to 3 future launch rockets in Europe. ISAR is one of them. They're German. They're interested in having us as contractors for the future launch to be able to do quickly a detection of satellites as soon as they launch. Something I should mention is that we can also have those enclosures moved around. I mentioned that we are building those. So that means that if a partner contacts us and say, we are going to launch next week, and this will be roughly our trajectory, we can deploy those stations along the path of the trajectory or optimize it so we can always see those satellites which has just been launched. This is kind of a good way to react in case of a complex launch or complex maneuver between satellites.
Absolutely. Thank you. That's it. Yeah,
Thank you very much. And sorry again.
Absolutely. No, pleasure to have you. Thank you for everyone who joined the showcase. That's it. We are that's it for today. Thank you for everyone who joined. I apologize for some of the technical difficulties had along the way. For those who remember them, hopefully most people don't remember them. But have a good rest of your day and stay tuned for next month. We're going to have a Future of Computing showcase. And thank you again to all the companies and panelists who joined us today. You guys really made it great. Really appreciate all the effort and have a fantastic rest of your day.
Thank you,
Great.
Asher.
Thanks, Asher. Take care.
Absolutely. Have a good one.
Thanks, Asher.
Yep, absolutely. Have a good one.